Our objective for today, I can simplify exponential expressions with fractional exponents. Read together, 1, 2, 3. I can simplify with fractional exponents. So if you notice last week and the 2 days from the previous week, we were working with exponential expressions, but the exponents were whole numbers or integers. You guys remember that? Yes, we love those. All right, good. And we did the multiplication properties and division properties. All right. Well, today we're going to start now cranking it up a notch, and now the exponents are going to be fractions. Let's go. So, what should go in your Farrell model? Exponential expressions, right? Fill that in. I'll give you 1 minute. One example, one unexample, one hashtag, and your definition. By now, you should know this. I'm giving you the heads up. I've been giving you plenty of practice because it's coming up on the big party. No, it's an individual party, and it's close to 23 questions. Yes. Yes, I'll let you guys know. Anyways, does it look something like this? Okay, you'll finish that on your own. Write these steps down underneath your Farrell model. Step number 1, it says rewrite as a radical and factor the number completely. Step 2, identify the index and the radical to find the root. Step 3, raise to the power outside the parenthesis. And step 4, simplify. Copy that. If you have your colored pens, use your colored pens, please. All right, so check this out. There's some vocabulary here that I need to clarify. So writing utensils down, look up to the screen, please. Look up to the screen. Writing utensils down. There it goes. So today, like I said, we're going to be looking at fractional exponents. Step 1 says rewrite as a radical. So when I give you an exponential expression that has an exponent that's a fraction, we need to rewrite it as a radical. Some of you are saying, what is a radical? Well, let me show you. You used to know radicals as this symbol, which was known as a what? Square root. But from now on, we're not going to call it square root because now we're going to be using more than that. So now, from now on, it's called a radical. It also has a number here and a number here. All right, just by looking at it, turn to your neighbor, let them know the parts of this radical expression. Let me know the parts of this radical expression. Okay, let's see. Who used their colored pens? Okay, turn to you now to let them know what each part is according to the colors that you did. All right, so here we go. For those of you that didn't see it or that don't use colors, here it goes. The index is the number outside of the radical. The symbol that you knew as a square root is now known as the radical. The only one that I haven't given you a name for is this number inside. This is known as the radicand. Copy that, please. Radicand. Nice. All right. Now, the purpose of me asking you to get colors is because it's easier to transfer some of this information. So here we go. As you're finishing up. From now on, like I said, this is known as a radical expression. But are we in radical expressions? No, we're in exponential expressions, but we're going to convert them into this. However, I just wanted you to see all the parts. Now, this is how this works. Writing utensils down, look up to the screen. There you go. When you are given, pay attention please, when you are given a radical expression, to simplify this, goes as follows. Pay attention, please. Writing utensils down. You look first at the index. The index tells you how many times some number has to multiply itself to get the radicand. Here it goes again. To simplify this expression, you first look at the index. Call the index because it's indicating how many times a number multiplied by itself that many times gives us the radicand. So here goes the question. How many times does the number have to multiply itself?
3 times.
3 times. What number multiplied by itself 3 times gives me the radicand 8? Tell your neighbor, please. The correct answer is 2. 2 times 2 times 2 is 8. Tell your neighbor the name of this number that we just found. Those of you that used your pens. That is correct. The correct answer is root. Label that, please. And that's how you simplify these kind of expressions. We got it, yes? However, the main lesson today is to change exponential expressions that have exponents that are fractions to change them into these kinds. Okay? So, with that said, check this out. The other thing, before I move on, look at this question. What happens to an exponential expression that has a fractional exponent instead of an integer exponent? Here goes the question again. What happens to an exponential expression that has a fractional exponent instead of an integer exponent? So last week we said we did integer exponents, right? Today we're going to do what? Fractional exponents, okay? So check this out. This question you're going to use to fill out your summary section on your notes. What's the summary section? At the bottom, next to the objective. You don't have to copy the question. That's just something that you need to fill out by yourself. So what I'm trying to get you guys to start doing in your noodle at the end of the lesson, say, okay, what did I do last week and what did I do this, like today? Well, last week I noticed we did this, but today this is what happens to the expression with a fraction as an exponent. You answer that on that space. Everybody with me? All right. Next, before I get into the examples, let me review really quick because we're going to need some of this for later on. Prime numbers and composite numbers. I'm going to take you back to elementary school. Yeah, remember? Sloppy Joes and veggies and stuff, yeah? All right. That was so nasty. No. Yeah? That's cool. All right, here we go. A worm in the burrito? But was that done on purpose or? So she didn't like bite into it and it was hanging like this? All right, here we go. Look up, please. So here goes a review for prime numbers and composite. Look up, please. Prime numbers are numbers that have factors of 1 and themselves. Factors meaning or implying multiplication. So 2 is the first prime number because its factors are 1 and itself. Are there any others? No. No, wait. Any other factors for that one? No. Unless we get decimals, but we don't want to work with that. Next number. Is this a prime number? 1 times 3. Let's look at this one. 1 times 4 or 2 times 2. Therefore, if a number is not a prime number, therefore it has to be a composite. Here it goes again. Next number. Number 5. Prime number? 1 times 5. How about 6? No, 6 goes over here. 1 times 6, 2 times 3. How about 7? Yes, 1 times 7. How about 8? No, that's 1 times 8, 2 times 4. How about 9? No, 1 times 8 or 3 times 3. How about 10? Oh, my bad, my bad. I did that to see if you're paying attention. All right, 1 times 9. How about 10? 1 times 10 or 2 times 5. How about 11? No, that's a prime number, 1 times 11. Okay, so now we understand the difference between prime and composite. That was just a review. The other thing that your teachers had you do that day, they showed you how to find the prime factorization of numbers. And they said, okay, kids, we're going to build a factor tree. Remember that? And then they give you a number, and they say, okay, let's make a star for our tree. And here's our tree and the branches. You guys remember that? No? Okay. All right. So some of you use different methods, but here goes the method that I want us to use when we get to these. This is like a refresher. Here goes. I want us to keep in mind the first 5 primes: 2, 3, 5, 7, 11. And I want us to begin with one of those. Just in focus. So which one of these divides into 18 evenly? 2. What other one? 3. So I'm going to start with the biggest one. So that's 3. 3 times what gives us 18? 6. Now, check this out. I'm going to circle this one because this branch doesn't grow anymore because it's a prime number. This is not a prime number. This is a composite. So that means I have branches coming out of it. Which one of these primes divide into 6? 2, but also 3. I'm going to start with the biggest one, which is 3. And the other one is 2. I also circle it. I can't do anything else because all of these are prime. That means that these three are known as prime numbers. Everybody with me? Prime numbers. However, this process is called prime factorization. That means factors, implying what? Multiplication. So if I multiply these, they're no longer prime numbers. They are called prime factors. And what does that mean? That if I multiply them, it gives me the number I started with. 3 times 3 times 2, 18. Copy that on the Q column, I know, right? Copy that. So now that we did a review of some of these basic operations that we're going to need, now I'm going to get into what we're going to do today. Today, we're going to change exponential expressions that have fractions as exponents into radicals. Okay? Writing utensils down. I'm going to go over the example. You guys are paying attention, and then I'll have you guys talk about it, and then we'll go ahead and copy the whole thing. Okay? Here it goes. Okay, talk it over to your neighbor, let them know what's going on there. All right, let's see. Xavier, what's going on with all of these that have fractional exponents? What happens? The denominator becomes the what? The index. The base becomes the what? The radicand. So as soon as, does everybody agree that as soon as we see an exponential expression with a fraction of exponent, you make it into a radical? The denominator is the index, and the base is the radicand. Does everybody agree with that? Did it work all the way through?
No.
No. Do you have any questions for me? Helena? Why didn't we do the 2 as the index? Because in the past, all of us already know what the square root of 16 is, right? Which is, everyone? 4. Which means what? What number times itself how many times? How many times itself? 2. So do we need to indicate the 2? No. That's why we already know this is the only one that we don't write the 2 for. Copy that, please. In the back. Copy it in the back. Copy that. And then we'll do some practice ones with numbers so you guys can get a hang of this. We already did one with the number on the example where we did the steps, right? But I want to do some more for these. Copy that and go. All right. On the right side of that, let's change these into numbers. 9 to the 1/2, 8 to the 1/3, and 16 to the 1/4. All right. Let's change these to radical expression. Let's see. Start with the first one. Do we have a fractional exponent? Yes, so we make a radical. What is the denominator for that fraction? 2. Do we need to write it outside? No. What is my radicand? 9. Therefore, one number times itself 2 times gives me 9, everyone. And that is known as the root. Are we there? Okay, let's do the next one. Do you see a fraction? Yes, so we do the radical. What's the index, everyone? 3. What's the radicand? 8. Therefore, what number times itself 3 times gives me 8? 2. Do that last one by yourself. Hurry up. What'd you get, Justin? What? 2? Hands if you got 2. That is correct. Once again, this one, now I'm going to do this one all in black. Radical, because I see the fraction. 4 as the index, 16 as the radicand. One number times itself 4 times, give me 16. 2. We got it, right? Okay. Still a couple more. Copy that one. Example 1C. Let's see how you do. And this one they already did for you, right? You just need to find the number. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Tell your neighbor what is the root. What number times itself 3 times gives us 125? Everyone. 5 is correct. 5 times 5 is 25. Times 5 is 125. Okay? Next, example 2. Copy this one. crank it up a notch, yes? Example 2A. Copy this one. Hurry up, hurry up. Let's do this one all in black or with your pencil. Here we go. So like that, we don't spend a lot of time switching colors. Do we see a fraction as an exponent? So we do a radical. What's my index? 5. What is the radicand? 32. So that tells us that what number times itself 5 times give me the number 32. Everyone. 2. That is correct. 2 times 2 times 2 times 2 times 2 is 32. Bring down the plus sign. Do we see a fraction here as an exponent? Yes. Radical. Radicand is the 9. Do we need to write the 2 there? No. What number times itself give me 9? So what is 2 plus 3? 5. Piece of cake? Okay. All right. Let's crank it up a notch. Yes. Oh, yes. Example. Mega Michael Jordan cube. Here we go. Let's do 27 to the 2/3 exponent. Okay, writing utensils down. Right away, you guys notice something different, right? What's the difference on this one? That the numerator is greater than 1. But do we know what to do if it was a 1? Yes, that means I need to rewrite this. So look up. 2/3 can be rewritten as 1/3 times what? Times 2. Does everybody agree with that? 2 times 1/3 is what? 2/3. Do you agree with that? Therefore, I'm going to rewrite this. 27 1/3 times 2. You're just paying attention right now. Do we know what this is? Yes, radical 27 index 3. We have multiplication. Here it is. And what is the exponent? 2. Question. What number times itself 3 times gives us 27? 3. And if we take that to the second power, that gives us what? 9. Copy that, please. Yes. Nice, right? Piece of cake. So here the key point is you need to rewrite the this exponent to make sure the numerator is 1 and the denominator stays the same as 1/3. Okay? Before you pack up, see if you can do this one by yourself. Example, Power Rangers cube, 8 to the 2/3. 8 to the 2/3. Very similar to the one we just did. You got it? Helena, what'd you get? Close. Justin? 4 is correct. This became 8 to the 1/3 times 2. This becomes cube root of 8 to the second power. This becomes 2 to the second power, which is 4. Your home plate for tonight is found on page 35. Do all, only. Yeah, in the book. We're finally going to start in our book. Chon, chon, chon. Make sure you tear out the page and bring it tomorrow. Have a good one, guys. Enjoy your home plate. See you guys tomorrow. Bye. There is tutoring today. If I don't see you.